So we've plotted our graph using these results table, using this results table. If we look at the results table, the time is going up in equal amounts every 2 seconds. And then the velocity, to start off with, it goes 5, 10, 15, 20, goes up in 5s, right? And then it starts to go up in 2s for these 3. And then it doesn't change at all for these 3. Then it actually goes down for the rest of it. It goes down in equal amounts. It goes down in 4s, so 24 to 20, 20 to 16, 16 to 12. So it goes up in 5s, up to here. That's this first straight line. So when the speed is increasing by the same amount every 2 seconds, then we have, well, basically we have not just a, forget about whether it's higher or lower concentration, but the point is it's constant acceleration. The acceleration stays the same, right? And we'll leave it just as constant acceleration. If we look at the next one, well, the next one is also constant acceleration because it's going up in the same amount again, but it's different constant acceleration. So if I move, we'll take an arrow and we'll stick that here. And this is constant acceleration too. But you can see that it's going up in a small. Well, look at the results table. It goes up in it increases after 2 seconds. It increases by 2 meters per second. So it's a lower acceleration, isn't it? So this first one increased by 5 meters per second each 2 seconds. So this is a higher constant acceleration. And this one here, well, this increased only by 2 meters per second each time. So this is a lower constant acceleration. Okay. Now we've got between 10 seconds and 14 seconds, the speed's not increasing at all. So this is zero acceleration. There's no acceleration at all. So we could just say a constant speed or constant velocity. So that flat bit is constant velocity. Let's get a graph. Let's get another arrow here. Whoops. Okay, so that's constant velocity. So again, if it's steeper, it's higher acceleration. If it's less steep, like a more gentle slope, then it's a lower acceleration. This, by the way, is only if I'm talking about a velocity time graph. So velocity on the y-axis, time on the x-axis. But we do need to know that we can see from looking at the graph, it's got high acceleration at the beginning. Then it carries on accelerating, carries on speeding up, but doesn't speed up as quickly as it did to start off with. So it's slowing down, or not slowing down. It's just not increasing the speed as quickly as it was. And now it's reached the constant speed, and now it's slowing down. You see, because the speed is going down. See the speed, well, the velocity, speed, velocity, basically the same. Not quite the same thing, but as far as we're concerned so far, it's the same thing. So we would say, we could say deceleration. And it's a straight, the gap is always the same. It goes from 24 to 20, so that's a gap of 4 meters per second. Then from 20 to 16, that's also a gap of 4 meters per second. And 16 to 12, that's also a gap of 4 meters per second. And it's a straight line. So it's a constant deceleration. Okay, and you can see that if it was steeper, like this one's steeper, then it would be a high deceleration. It'd be slowing down really quickly. And if it was less steep, more gentle, then it would be a lower deceleration. Okay, so I'm just going to grab an arrow here, put that there, and I'll label that there. Let's just summarize that then. A straight line means constant acceleration or constant deceleration. Okay. So that's our first point. Let's just do it like that. So a straight line, all these are straight lines actually. They're all constant velocity, they're all constant acceleration. This one's constant acceleration as well, and the acceleration that it is basically zero acceleration. Okay, so we don't confuse straight with flat. Okay, so a lot of students I speak to, they say, "Oh, this is straight," and the other ones aren't straight. They're confusing straight with flat. That all these lines are straight. That's straight. That's straight. That's straight. I drew a straight line to make all of these, right? So they're all straight. So don't confuse straight with flat. So a flat line or horizontal line means means the car means constant velocity. By the way, what we need to also realize is that this, I'm only talking about, I'm only talking about velocity time graph here. For other graphs, it won't mean that, but only for velocity time graphs. Only for velocity time graphs, these things are true. A straight line means constant acceleration or constant deceleration. A flat or horizontal line means constant velocity, which is zero acceleration. And then a line going down, like the fourth one, line going down, in other words, from top left to bottom right, means deceleration or slowing down. Okay, so again, straight line, all these are straight lines, they're all constant acceleration. This one is zero acceleration, it's still constant, it just still stays at zero. A flat line, this one's also flat, the other ones aren't flat, they're slanted, they're diagonal. This one, this flat line means it's constant velocity, so zero acceleration. It means the velocity is not changing. The one that's going down, well, clearly the velocity is going down, so it's a deceleration. Okay, so that's the summary. That's something you need to be aware of. Okay.